Hey guys, welcome back to school. This is Mr. Martin's Physics, Lesson 1. Today I'm just going to run through Lesson 1 and give you some examples of scientific notation. Now, hopefully you've already looked at this slideshow before we've gotten to this video point, but before I get to my examples, I just want to point out some important slides and some things to do before you watch me demonstrate how to tackle scientific notation problems. So let's take a look here. And load. All right, this is our objective slide. You'll see one of these every time. As you can see here, the big takeaway from today is we are going to be able to solve measurement problems involving scientific notation. The things you should need or should have in front of you is a pen or pencil and notebook, and access to Google Docs. You will have shared your daily work, lesson 1 and 2 document. You guys all have one of those in Schoolology, so that's going to be very important as you go through. Our first slide is what is physics, right? It's a big topic in science, so I found this short little video that breaks it down in about 2 minutes. So what I need you to do now is pause this video, go back to the slideshow, and watch this video before you move on. Great, you watched it, you're back, you went to the next slide, and now there's a stop and write. In your daily work, lesson 1, week 1, you'll find this prompt here. The answer can be found in the video, so that way I know you watched the video. So take the time, stop now, go back, answer that question before you move on. Cool. Let's get into it. Scientific notation. I'm a big fan of this Math Antics YouTube video. They have a bunch of resources. So even if you're doing geometry or algebra, I really recommend checking out Math Antics on YouTube. This guy teaches all kinds of different math in a very easy way to digest. He's kind of silly, kind of fun. He's even a little corny, but that's okay because he teaches it really well. He can even do it better than I can. Yes, this video is a bit longer. It's about 10 minutes. I really recommend you watch this. And in fact, I don't recommend it. It's like mandatory. Check it out now before you watch me do my examples. Make sure you're taking notes. All right, so I watched the video myself. I took 3 important notes. These will help you navigate through scientific notation problems. Once again, stop here. Go back to your Google document on Schoolology. Your important takeaways, make sure you get this information, all 3 of them on there. All right, next slide. I gave some notes, so I will also give PDF versions of this to kind of help you think of how to approach a scientific notation problem. I gave you both positive and negative exponent examples. If you want, what I would do is pause here and either write this all down yourself on your own notebook so it makes sense to you, or if you have a printer, that's awesome. You can print out the PDF version yourself. All right, here's the important part. Now, I'm going to stop right here. I'm not going to go any further in this slideshow, and I'm going to switch to my document camera. Here is where I am going to give you some examples. All right, it looks like I'm back. Here we go. Let me pull up my document camera for you guys. All right, so here we see my example number 1. Write the number in scientific notation. As you can see, we got 2 fairly large numbers here, 67,590, right? 67,000 is a large number, and as we learned from the videos, you want to use scientific notation to express large numbers. So when I look at a problem like this, the first thing I want to know is, what am I writing it in? Of course, we see scientific notation, so I know it's going to be a number times 10 to some exponent. All right, so in my brain, what I'm thinking when I attack these problems is I know I got to put a decimal place, right? So originally in standard notation, you would find the decimal place here, right? But I watch the videos and I know this number is way too large to use in scientific notation. I'm looking for something that's greater than 1 but less than 10. So I see a 6 and a 7 here. That tells me I want to start with 6.7. Put that there. Now I know I'm going to start setting up my answer a little bit here. I know I'm working with 6.7. I'm going to put 6.7 times 10 to something. I don't know what it is yet. All right. I watched the video and I know now at this point I really want to start moving that decimal place. 1, 2, 3, 4. I have 1 peak, 2 peaks, 3 peaks, 4 peaks, right? 4 peaks tells me my answer is now 6.7 times 10 to the 4th. Remember, I moved the decimal point to the right, so I know it is a positive exponent. Let's do that again with the next problem right below. I have a not so large number, but we can still write it in scientific notation. That's okay. I have 590. When I approach these problems, I always like to just start with where would the decimal point be originally, right? That's going to tell me an endpoint. But once again, I know I'm looking for a number that is between greater than 1, less than 10. I see a 59 right there. I'm going to put my decimal point right there. Cool. I see 5.9 now. That's what I'm going to start with. Times 10 to something. Okay, let's move that decimal point. 1, 2. I have 2 peaks. I went to the right, so I know it's 5.2 times 10 to the second. Once again, I went to the right, positive exponents. Let's see here. Let me see if I can pause this for a second. If I can get out of my document camera. Bring that down and pause. All right, I am back. Let's look at another couple examples here. Notice while I make this full screen, here we go, that we have small numbers this time, right? We have 0.0089 and 0.000093. If you're anything like me, that's way too much writing to do. So let's once again use scientific notation to this time represent really small numbers. So once again, I know I need to do something with this decimal point. This is too much writing. I need a number times 10 to something. So let's just even start with just writing that. A number, some number is going to go there, times 10 to something. All right, you know the exponent can be positive or negative. I know I got to do something with this decimal point right now. This number is not going to fit here. So I notice I have 8 and 9. If I put a decimal point right between the two of them, I now have a number 8.9. 8.9 is greater than 1, but less than 10. So I know 8.9 can be my start number. Once again, I know I got to do something with that decimal point to get it back to where it originally started, so that way we know what the original number is. I'm going to move it. I got 1, 2, 3. 1 peak, 2 peak, 3 peaks. Once again, the number of places I move it, I know that's my exponent, but we got to think about this for a second. I went to the left this time. And I remember from my notes in the video that when I go to the left, it is a negative exponent. So I know the answer in scientific notation is 8.9 times 10 to the negative third. Let's take a look at this giant one here. That's a lot of zeros. I don't want to write all those zeros every time. It's easier for me to write this in scientific notation. I see two numbers here. I'm going to put my new decimal point there. I know that I now have 9.3 times 10 to something. I'm not sure yet. What is it going to be? Let's move the decimal point. 1, 2, 3, 4, 5, 6. I went 1, 2, 3, 4, 5, 6. I went 6 places, put 6 as my exponent, and once again I went to the left, so I know that is negative 6. I'm going to pause again while I set up some standard notation problems. All right, I'm back. Now we're going to take a look at a couple of standard notation examples, right? So what we're given is 2 examples already written in scientific notation, but for the sake of this problem, we need to get it back to standard notation. So when I look at a scientific notation example, I see 3.5. First thing I'm going to do is write down 3.5. Take that from there and write down 3.5. I also now know from the examples before, the exponent tells me how far I have to move the decimal point, right? We do that with these big loops and points. So I see a 7. It's a positive 7. So I know it has to go to the right. Positive to the right. So I'm going to take that decimal point and go to the right and hopefully make a really big number here. 1, 2, 3, 4, 5, 6, 7. Now, right at the last point there, you can go ahead and put your decimal point. And good practice is right after the last point, put another 0. That way you know it's another number. Now it's a sloppy 0, but that's all right. Now we have all these loops and valleys, but we got to put some zeros in there, right? So I have a 0 in there. I have a 0 here, and so on and so forth until I get all the way to that decimal point. And if I want to double check my work real quick, I have 1, 2, 3, 4, 5, 6, 7. So I moved the decimal point 7 places to the right because it's positive. There's the end point and the 0 for good fashion. So let me rewrite this so it's nice and clean as my answer. I got 35 and I have 1, 2, 3, 4, 5, 6 zeros, 0.0. If you want, I'm okay with that. If you want to take it to the next level, I'd really like to see some commas in there so we know how big this number really actually is. It looks like 3.5 times 10 to the 7th comes out to 35 million. All right. So let's take a look at this next one. I have 2 times 10 to the 5th. Now, for the most part, we've had like a number with a decimal point and a number after it. This one we don't. If you don't see anything after the whole number, you can always put a decimal and a 0. So I have still 2.0. I didn't change the number at all. I'm just noting that there was a decimal there. So once again, I see 2.0. I want to start there. I see to the 5th power. It's positive, so I know I'm going to go right. Let's move that decimal point. I've got 1, 2, 3, 4, and 5. Just like I did before, I'm going to put the new decimal point right at the end of the loops. I'm going to throw a 0 on there for good posture, and I'm going to fill in my holes. We got 1, 2, 3, 4. I want to double check my work before I write my final answer. I should have 5 numbers above my original one from the moving point. 1, 2, 3, 4, 5. Right on. My answer written nice and clean. 2, 0, 0, 0, 0, 0, 0. Ooh, it's right there. My fault. I'm okay with this, but once again, let's make it nice and clean with some comma. 2 to the 5th power, or times 10 to the 5th power, comes out to roughly 200,000. All right, I'm going to pause again, and we will take a look at using negative exponents. All right, I'm back one final time. We're going to look at some standard notation or scientific notation problems that we want to write in standard notation with negative exponents. Let's get this thing on full screen and we'll get going. Cool. So the first one I see is I have 1.74 times 10 to the negative third, and I have 4 times 10 to the negative fifth. So whenever I see a negative exponent, the first thing I know is I'm going to move my decimal point to the left. Right? Negative is left. That's an ugly arrow, but it gets the job done. So when we're approaching a scientific problem or scientific notation problem with a negative exponent, it's pretty much the same setup. First thing I want to do is take what I have and move it down. But since I'm moving it to the left, I'm going to move over here on my page a little bit so I have some room to work. And then from here, the process doesn't change. All you need to know is negative goes to the left. So negative 3, I'm going to move to the left 3 places. 1, 2, 3. Just like before, I'm going to add my new decimal point. But even more important than when it's positive, you have to put a 0 here. This lets us know it's a very small number because it is a negative exponent. And then you can fill in your new zeros in the empty values. 1, 2. I have some empty values there. And if I want to double check my work once again, I should have 3 numbers inside my values. 1, 2, 3. I am golden. Let's clean this up so the answer looks nice and neat. So I have, for my final answer in standard notation, 0.00174. That's a nice small number. Remember, negative makes small numbers, positive makes big numbers. So that's a quick hint. All right. Again, we have a number with no decimal point with it, right? We have 4. Just 4 by itself. Negative 5. Negative tells me to the left, but we have 4. Remember, you can always put a decimal point, a 0. That doesn't change the number. It just helps you visualize where that decimal point would be if you need it. So once again, it's negative to the left, so I'm going to start a little bit further to the right on my page so I have space to work. Now, notice I just put 4 point. You can do 4.0, that's the same exact number, but in the end, our answer, we just want that 4 by itself. So I'm going to move this decimal point 5 places to the left. 1, 2, 3, 4, 5. A little too far over there. Put my new decimal point right at the end of where I stopped moving. And once again, just like before, it is very important to put a 0 after the new decimal point to the left of it. And again, I'll fill in my values with zeros. 1. If I want to double check my work, I should have 5 numbers inside the valley. 1, 2, 3, 4, 5. I know that is correct. Now I can just write it nice and clean on my answer sheet. So my answer is 0.00004. Right. I will pause there. I don't want to share this. I want to go and present. All right. So those were 4 examples. Well, this loads. There it is. Those are 4 examples of scientific and standard notation problems. We had positive, we had negative exponents. Now it's your turn to practice, right? So hopefully you've used every resource I gave you. Be sure to come to office hours if you still have questions. I'm available quite often, and my link is in our Schoolology class. You will find in your daily worksheets, lesson 1 and 2 is the title of it. There's independent practice for lesson 1. That is for a daily work grade. So make sure you're completing that as soon as possible. Thank you.